Now let's try something new. Let's try look at a 2D problem without diagram. Alright, so the biggest challenge in this question is to recover the correct diagram. Not just recover the diagram, but to recover the correct diagram. Alright, so we have 3 points A, B, and C. We have the bearing of A from B is north 35 degrees west. The bearing of C from B is north 76 degrees east. So now think about the relative positions between A, B, and C. Right, up, down, left, right. And we have the distance between A, B is 40 kilometers. The distance between B and C is 130 kilometers. Alright, so we find AC, the bearing of A from C, and part C once again is a new thing, the shortest distance between B and AC. So most importantly, I think, is to recover the diagram. Alright, it's the utmost important thing in this question. If you get the diagram wrong, then I don't think you can get the rest correctly. So let's see. For point B, there are things going in the north something west. Alright, north something west is in this direction. So if this is point B, if this is point B, alright, then there is something in this direction. This is in the direction of A. And then north 76 degrees west, that means it's something like here. North 76 degrees east. This is north going east, alright, so point C is somewhere here. So roughly we have the idea. B is at the bottom middle, alright. C is on the upper right and A is on the upper left, right? So that's usually how I estimate the diagram if I have to, alright. I would first draw a rough sketch. So now I know, alright. Point B will be somewhere at the middle bottom. Things are going up to the left and up to the right. So point A will be north 35 degrees west. 35 is a rather small angle, right? So I guess point A will be here. Alright, this is point B. Point B is the center of everything, now we know. And this purple angle goes to 35 degrees, right? What else do we know? We know that point C is 130. Point C goes here, but it's much longer. It's much longer than BA, alright? So I guess it would be somewhere here. I hope I'm not mistaken, alright? And this angle, this orange angle, goes 76 degrees. This orange angle is 76 degrees, okay? So I guess point C is kind of like here, alright? So let me put back the direction, kind of like this. That is the relative positions between A, B, and C. Alright. Let me put back point A. Okay, so point A is kind of like this. Alright, and this orange line is 130 kilometers. The purple line is 80 kilometers. Alright. Okay, so what does it ask for? First, it asks for the distance of AC. Alright. So this is the distance between A and C. Alright, so it is like this. Well, once again, we have to find the focus triangle, but is it pretty obvious, right? The focus triangle will be triangle ABC. We have the red, the purple, and the orange for the triangle A, B, and C. And we have to find 3 pieces of information. So let's see how much do we know. We know the length of the purple line is 80 units. We know the length of the orange line is 130. Alright, so we need one more piece of information. So what else do we know? We know the angle between them, this angle, right? Do we know the angle between them? Is from the diagram, you can see that if you draw the correct diagram, you can see the angle between them is 35 plus 76, so it's 111 degrees. Alright, the angle between them is 111 degrees. So it is a typical SAS situation. SAS situation. So we can use cosine law. SAS cosine formula to find AC. Use SAS cosine formula. Alright, you can write down the formula, or in DSC, we accept you use the calculator to get the value. Alright. Most importantly, you have to give the values of these 3 quantities SAS. So I use the calculator to find out the length of AC will be 175.37 kilometers. Alright. This is the length of AC. Alright, so far so good. And then next up is okay. And then next up, we want to find the bearing of A from C. Bearing of A from C means that the angle is around C, right? We should look at the angle around here, but not here, nor here, all right? Because the bearing is from C, all right? So the bearing of A from C will be, the reduced bearing will be this one, all right? North 30 degrees west, or the whole circle bearing will be this one, all right? Remember, whole circle bearing rotate clockwise, all right? So either way is okay, right? I'll give you both answers, but let's do it with the reduced bearing. Let's look at this green angle, all right? Now, how much do we know about this green angle? How much do we know about angle around C, all right? Not much. Perhaps we know this is also 76, right? Because once again, the northern direction, the southern direction, they are parallel. So we use our interior angle. We know that these two orange angles, they are the same. All right, this is F76. Oh, now you can see if I can obtain this blue angle, then I can have the green angle. Am I right? If I have the blue angle, you know the green, the blue, and the 76, they add up to 180. So that means I need to find this blue angle now in this focus triangle. All right? We can find this blue angle in the focus triangle. So like I said, there are two ways you can find this blue angle. All right, the first one is via sine formula. We have sine theta divided by 80 equals to sine 111 divided by the red line, right? We know AC. We know this 80. But like I said, I would rather not use this approach. Do you remember why? Why wouldn't I adopt this approach? It's okay, but it's not the best approach, all right? Because when you use sine formula to find angle, you run into the dilemma of choosing the angle from the calculator or 180 minus, right? Even though the diagram looks like it should be an acute angle, but you never know. I did not draw the diagram to scale. All right, so they may be the acute angle, it might be the obtuse angle, especially it looks like that the answer, they are quite close. So it's okay to use the sine formula, but you run the risk of choosing the wrong angle at the end, all right? So I would rather adopt the cosine formula. That cosine theta is 130 square plus AC square, all right? And what else? And then we have the orange line is 130 square, and then subtract the purple line. Right, the purple line is 80 divided by, this is the triple S cosine formula, twice AC and 130. All right. For AC, I would use the more accurate value rather than the round off value. Like I mentioned earlier, beware of rounding error. All right. This is triple S cosine formula. All right. So we obtain theta equals to, according to my calculation, is roughly 25.21 degrees. Okay, so this is theta. This is my preferred approach in finding angle using cosine formula. Rather than use sine formula, you run the risk of choosing the wrong angle from the ambiguous case of arcsine, the inverse sine function. For cosine, there's no such problem. If this gives you a negative number, that means it is an obtuse angle. Cosine theta is negative if theta is obtuse, all right? So anyway, theta is 25.21, but that's not the answer yet. We have the green angle, right? The green angle, let's call the bearing beta. Beta will be 180 degrees minus the orange angle, 76, minus the blue angle, 25.21, all right? And beta goes to 78.8 degrees, all right? So you can write the answer statement. The bearing of A from C equals to north 78.8 degrees west. West. Right? If you want the whole circle bearing, if you want the whole circle bearing, you have to take 360 degrees minus that number, and that is if you want the answer to be in the whole circle bearing, that would be 281.2 degrees. All right. It depends on what kind of answer they expect, right? It can be the reduced bearing, it can be the whole circle bearing, all right? If that's not required in the question, either one will be fine. All right, so much about part B, okay? All right, so the first important thing is to locate the bearing. Bearing of A from C, you should find it around C, all right? Not around A, but around C. And then you look at which angle. Now, the green angle beta is not in any triangle, so we need a helper angle. The helper angle comes in blue, all right? The blue angle, we can find it from the triple S cosine formula. We can use the triple S cosine formula to find the blue angle, and some further manipulation, we get the green angle. And finally, you express the answer as either bearing, all right, a reduced bearing or a whole circle bearing. All right, so far so good. Now let's take a look at the final part. Find the shortest distance between B and AC. All right, shortest distance between B and AC, part C. All right. Now, how do you find the shortest distance between 2 points? It's simple. Between 2 points is the straight line. How do you find the shortest distance between a point and a line? The shortest distance is the perpendicular distance from the point to the line. All right. So the shortest distance between between B and AC, the shortest distance between B and AC will be this particular yellow line. All right, it goes through B and is perpendicular to AC. All right. Now, but the point is, we don't know where this intersection point is. Let me call it P. All right, we have no idea where P is. All right. Now, to do that, there are 2 ways you can do that. All right. One is specific, one is more general. Specific means that it is applicable in this specific question. If you look at the yellow, orange, red triangle, yellow, orange, and red, you discover that it is a right angle triangle. All right. It is a right angle triangle. We know one of the line, it is 130. We know the blue angle. How large is the blue angle? It's 25.21 degrees, all right? So we can use sine ratio to get the yellow length. The yellow length is BP, all right? This is the shortest distance between B and AC. So we get that BP divide by orange 130 equals to sine ratio, right? It's very important that you get the sine ratio, cosine ratio correct. All right, which side divides by which side, which is on top, which is at the bottom. All right, it's very important that you know this. Okay. Okay, let me go back to the page. I just clicked on the wrong place. All right, good. So we can use sine ratio to get this. This is sine 25.21. So we have the shortest distance between them equals to that is 55.4 kilometers. All right, that is the answer for this one. All right. Now it's happened in this case that we have a complete right angle triangle. We can get the length. We can get the length of the horizontal line, all right, the perpendicular distance from B to AC. Now there is another way I want to share with you. It's a more general way. We can find the height without realizing what is the foot of perpendicular, without knowing the point P. All right, we can do this. We can look at the whole triangle. That's an interesting idea. We try to express the area in 2 different ways. All right, now these are what we know. All right, we know the orange line is 130. We know the purple line is 80. All right. We know the length of AC is in the red number. How much is the red number? It's 175.37. All right, we know the red line. All right, plus we know the angle in between. This is 111 degrees. All right, so we can express the area of the triangle in 2 different ways. We can express it as half AB sine theta, 1/2, 130 times 80 times sine 111. All right, this is half AB sine theta. This is one way we get the angle. We get the area. There's another way we can get the area is half BH. All right, half BP. All right, that is the height, and then the base times 175.37. All right. So using the area as a connector, we can connect the area in one approach and the area in the other approach to find the only unknown BP in the question, all right? And let me punch it on the calculator. The BP is also 55.4 kilometers. All right, we know the area can be expressed into can be found in three ways. It can be half AB sine theta. It can be half BH. It can be the Heron's formula. Okay, so we can use the area as a bridge to express the area in two different ways, so that sometimes you can connect this one with this one. All right, sometimes you can connect this one with this one, and so on. Right, it can be very helpful if you have the idea of the area to find the heights of a triangle. Usually, it's for finding the heights of a triangle. Okay, so this is it for the investigation on bearings.